Okay, 2012 questions. Okay, so number 78. Not too bad, I don't think. But there's some tricks to using your calculator and using it quickly. All right, so this graph it crosses the x-axis at one point from 0 to 1. What is the slope at that point? Well, slope means derivative, so I need to find the derivative at that point. Okay, that's what we're trying to find. But first I got to figure out what point we're talking about. Once I find that point, I'll use nderive to get the slope. All right, so first we're going to find that point where it crosses the x-axis. So just graph this and look for and make your calculator give you the exact x-intercept. Okay, so let me switch to my calculator. Okay, so plug it into y equals. Make sure your mode is always set to radian mode in calculus, which is the default. So unless you're in another science class where you change it to degrees, it should be in radian mode. Okay, I'm going to graph it. And I'm looking for the x-intercept. Okay, it says it crossed the x-axis between 0 and 1, and I can see that it does. Now I just have to actually find that point using my calculator, and don't round it. Keep all the numbers because we still have to find the derivative at that point. So to calculate something on your graph, you hit second and calc, which is trace. We want the 0, option 2, either arrow down or hit 2. Get to the left of it, already kind of to the left of it, hit enter. Get to the right of it, or type a number to the right, hit enter. And hit enter again, nobody cares about guessing. And that's the number that we need to find the derivative at. So we're now going to do nderive at that point, 0.6061193. Now here's a trick. You could write down on your paper that x-coordinate, 0.606, write down all those numbers. Or here's a little trick. Your calculator will store that x-coordinate until you use it again. So I'm going to do second and quit to get back to my regular computation screen. And I'm just going to type an x, a regular old x, and enter. Does that look familiar? That's the same x that was on your graphing screen. Now, because you've just displayed it, now you can use it when you do nderive without having to store it. So now we want the derivative at that point. So nderive, math 8. I normally just type in 8, but I'm doing that for you. Okay, math 8. An x always goes in the first one. In the big box, I could either retype that equation, or it's already in y1, so I can do vars, y vars, and there's y1. Okay, and here's the advantage of what I showed you. Now, instead of typing in all those numbers, which I can do because now I can see them, or I can use the answer button above the negative. Second answer above the negative. And it's going to plug in that 0.606 there. So the derivative at 0.606 would be 2.961, which is option D. Okay, so next we're going to do number 82. Try it on your own first. Hit pause. Okay, number 82. Remember, don't pick up your calculator before you pick up your pencil. What I mean by that is justify your answer, even though they don't ask you to. Write down the justification so that you know what you're looking for before you get distracted by that calculator. So for this one, we're looking for a maximum. So write down the definition of a maximum. Derivative is 0 or undefined and changes plus minus. Okay, well, this is a derivative equation. So my justification and my graph match. If they match, you're looking for height. So this translates to height is 0 and changes from above to below. Height is 0, means x-intercept, and sign changes from positive to negative, means above to below. So make sure that you know what you're looking for. So if you have an x-intercept, you want one that goes from above to below. Okay? Get that straight in your mind before you pick up your calculator. Okay, so we're looking for the x-intercept where it goes from above to below. Switching to the calculator now. Okay, so I plugged it into the y equals screen, and now I'm going to graph it. And I can already see the answer even though I'm not zoomed in correctly. If you ever want to go back to a standard Zoom screen, that's Zoom 6. I'm going to do it even though I don't really need to because I can see the answer. So again, we were looking for an x-intercept where it switches from above to below. Hopefully you can see that that is right there, right here, okay? But now I need to make my calculator get it for me. But before I bother spending the time, I can see that the answer is somewhere between 0 and 1 maybe. So I'm going to at least scan the answers and see if there are any that are, if there's more than one that are between like 0 and 1. So let me scooch this over, see what I have for answer choices. Are there any others? Okay, I'm not going to know whether it's C or D. So I'm going to definitely have to graph this to find my answer. So here we go. We're looking for that point right there, okay, which is an x-intercept. Second trace. X-intercepts, that's a 0. Get to the left of that point. Hit enter. Then get to the right of it, but not so far to the right that you include the other x-intercept. Hit enter. The calculator's going to look in between those. Hit enter again. And I get the 0.350, okay? Now, also, that's the direct way to do it. The other choice we could have done, since we knew it was either C or D, we could have also hit the trace function and see which one it's closer to. And I still would have said C, okay? So option C. Okay, moving on to the next one if you need it. Number 84. Hopefully you're starting to get the hang of these because they're pretty similar now. Okay, make sure again you pick up your pencil before your calculator. We want concave up. Oh, sorry, I said that wrong. Concave down. So we're looking for second derivative negative. Okay, second derivative justification on a first derivative graph. We are one derivative away, so that means slope is negative. So we're looking for downhill. That's what we're looking for right now. And they gave us a window. So if there's more than one place, we just want that section of the graph. Okay? So we're going to graph this and look for where slope is negative. Switch into the calculator. Okay, so I put it into the y equals screen, double checking my exponents. All right, it looks good. I hit graph. I may have to change the window though. We're looking for downhill. All right. There's more than one downhill, so let's change the window. They said it was what? I can't remember. It was between negative 1.5 and 1.5. So I'm going to change my window. Negative 1.5. And you can't hit minus. You got to hit that negative 1.5 to positive 1.5. And we're looking for downhill. Okay, even on that window, there's still two answers. We want the part that is here downhill and the part that's here downhill. So now I'm going to see, can I find that answer just by looking at my choices? Because this started at negative 1.5 and it looks like it's just shy of negative 1. And then again from 0-ish to another 1. So let's see if there's only one answer that has that. So I'm pretty sure by eyeballing it, I'm pretty sure that the answer is D, going from negative 1.5 to hopefully negative 1, and from 0 to 1. But just to be sure, in case any of these other answers are close, but I don't think they are, I'm pretty sure the answer is D. But a quick check is to use trace to trace it and make sure that this really is negative 1 and 0 and 1. Okay, so I'm just going to double check by hitting trace on my calculator and make sure it really is negative 1.5 to negative 1. So I hit trace, and I'm at 0 already, so let me just arrow to the right and see if that goes to 1, which I'm pretty sure it does. By the way, also, once you hit trace, you can also just type in the number 1 and enter. And yeah, that's that point. So I'm pretty confident that that's what that is. D. Okay, hopefully this is getting better. For the next part of the test, 2013, try to do it on your own. We'll see how you do.